Today we talked about how to find the area of different quadrilaterals, like parallelograms, trapezoids, and rhombuses. So if you look at this problem right here, we have a parallelogram. That means that both opposite sides have parallel lines. So these red ones are parallel to each other. The orange is parallel to each other. So I want to find the area of this. It's going to be the base times the height. Now the base is this bottom part here, okay? The height is how tall it is from the top to bottom. The height is not this. It's not this diagonal part. If they gave you a number that's on this diagonal part, they're trying to trick you. So let me show you why it's the base times the height. I'm going to cut a triangle here, and I'm going to get rid of it. I'm not going to get rid of it. I'm going to move it over here, okay? I'm going to do this, like this, all right? And I'm going to erase it off of this side. So now we have a rectangle, okay? Notice that I didn't actually take anything away or add anything. I just took the triangle that was over here and I moved it over here. So now that this is a rectangle, it's really obvious to see that, you know, this is the base, 13, and the height is just basically like this straight side, 9. So 13 times 9 would be our area. And that's how they came up with the formula for finding the area of a parallelogram. But anyway, it's base times height. So I'm going to multiply these out. 13 times 9. 9 times 13 is 27. 9 times 1 is 9, plus 2 is 11. And so it's 117 square inches. And the reason area is in square inches is because you can cut it up into a bunch of squares, a bunch of flat squares. Okay, so now we have a trapezoid. As for our next problem. Now, if I were going to put another trapezoid right next to this trapezoid, and I had that was exactly the same size, I would have a parallelogram. And I know how to find the area of a parallelogram. It's the base times the height. Well, the base here is going to be the base of this trapezoid plus the top of the other trapezoid. Now, if they're the same exact size, that's just this, so that's 9. So my base is going to be 15 plus 9, which would be 24. So now I have 24 as my base and 14 as my height. So I multiply those out and I get, I'm just doing it fast so that we can get to the geometry part, 336. Now that gives me the area of this entire parallelogram, but we weren't finding the area of a parallelogram. We were finding the area of a trapezoid. But notice that this parallelogram is just two trapezoids stuck together that are the same size. So I can just take this and cut it in half. I take 336 divided by 2. Pick a different color. 2 goes into 3 one time. 2 goes into 13 6 times. 2 goes into 16 8 times. So I get 168 square centimeters. Now, that's how they came up with the formula. Now let me show you the formula. Base 1 plus base 2 times the height times 1/2, or 1/2 height times the sum of base 1 plus base 2. So this is one of the bases, this is another base. So I'm going to add these together. Okay, so I get 24. So now my area equals 1/2 times the height times 24. So remember, this is base 1, this is base 2, and this line that's going up and down, that is the height. So height is 14. So 1/2 times 14 times 24. Okay? So I could multiply 14 times 24, but there's a little easier thing you can do, which is to just do this first part, 1/2 times 14. If I do that, half of 14 is 7. 7 times 24. So I multiply 24 times 7. That's an easier multiplication problem than what I did before. 4 times 7 is 28. 7 times 2 is 14, plus 2 is 16. So once again, I get 168. There's a lot going on here in this trapezoid formula, but if you just plug in the numbers and just multiply it out, you will get the area of the trapezoid. Remember, this top one is B1 or B2, it doesn't matter. This bottom one is B2, and this is the height. And you just replace those letters. Okay, and then you just add these and multiply everything else. So 3 is a rhombus. Now, rhombus is a parallelogram where all the sides are exactly the same length. To find the area of a rhombus, well, let me tell you how they got that formula. For this one, you use the diagonals, okay? So let's say I cut this up into diagonals. Actually, I'm going to go to another slide to illustrate this better. Here it is, finding the area of a rhombus. So if we took this rhombus here and cut it up along the diagonals, we could reassemble it into a rectangle here. And once again, we have our base and we have our height. We know how to find the area of a rectangle. It's very easy. Now the base here, you'll notice you have this blue triangle here that's in the middle. Well, it's the same as this blue triangle. So this base here is one of the diagonals. We'll call it D1. And then this height here, that's just this little half of a diagonal here. So this is 1/2 of the other diagonal. Okay? So that's how we get the formula 1/2 the first diagonal times the other diagonal. So let's go back to our problem. And we have 1/2 the first diagonal times the other diagonal. So we have our two diagonals. That's the line that goes across diagonally. So I have 1/2 times 18 times 11. I can do this part first. 1/2 times 18 is 9. Then I multiply that by 11 and I get 99 square inches. And that's how you find the area of a parallelogram, a trapezoid, and a rhombus.